I was very pleased with the MPLAB X data visualizer's variable streaming operation, but the data visualizer has a more advanced section, the DVRT session. The data visualizer runtime session will allow for the reading and writing of global variables, and it sounds very useful. Last time I was only using pin 7 of the PIC-Kits5 data streaming interface. Now I will need both pin 7 and pin 8 connected, pin 8 being the data output from the PIC-Kit5. So pin 7 of the PIC-Kit5 will connect to PA6 on the AT-tiny402, and pin 8 of the PIC-Kit5 will connect to PA7. That should be it for the hardware changes. There is not a lot of information in the data visualizer's user manual about the DVRT protocol or how to set it up. It does point to some example code to use, but there seems to be only one example, and it's for a PIC16F18446 project. Hopefully that will be enough. The user manual does say to include the DVRunTime.h and the DVRunTime.c files into your project. I'll put the files in my Tiny402 project. I think the UART in the AT-tiny402 is quite a bit different than the UART in the PIC16F184XX series, so I expect I'll have to modify this a bit. I'll take a look at the .h file first. Okay, there's not a lot to it. A bunch of defines at the bottom for the UART interface. I'm not very good at macros, so this might be a problem. Now the .c file. Again, not a huge file, so that's good. At least maybe it'll fit in the AT-tiny402. Let me compile it and see what the errors look like. Okay, quite a few. Now the macros need to be defined. I'm going to copy what I can from the USART0.c file that the MCC produced, really just as placeholders right now. Let me go over some of the other errors. First is the _RAM is unknown error. I guess that is not a valid qualifier for this chip. I'll remove those, as I don't think anything should be needed there. A capital extern, unknown type name. I'm drawing a blank on this. I just don't remember running across an all capital extern, and I don't see dout_buff defined anywhere else. I'll just remove it. There is an LED toggle in the DVRT_process function. I don't have any extra LEDs hooked up, or the I/O lines to spare, so I'll comment out that line. Okay, it now compiles without any errors. I did change a couple of defines at the top of the header file. I do want an interrupt-driven transmit, otherwise it will just block till the USART output register is ready. And the number of dynamic variable pointers, this will affect the size of the transmit buffer. I dropped it down to 2. Even though I only see using 8-bit and 16-bit values, I'm going to leave the buffer sized for two 32-bit values. Maybe change that if I get it working. When you only have 256 bytes of RAM, just can't go throwing around buffers here and there. Going to start up the MCC and make some changes to the USART 0 module. Setting the buffer size to 2, the minimum as these won't be used. Enabling the receiver and enabling the receiver interrupt. On the register tab, I'll disable the RSX interrupt. I'm not sure if the MCU is not in a power down state, if that even has any effect, and I don't really want to find out right now. Going to need PA7 for the USART input. Again, have to turn off the PA0 output and turn on the PA6 output for the USART. Generate the code and should be ready to go. I'm putting the DVRT_initialize call right before I turn on interrupts. In the example code, it was called after interrupts were turned on. I'm calling the DVRT_process in my MS-tick routine. Should be called every 1 millisecond. Of course, it didn't work the first time. Really didn't expect it to. In looking over the transmit callback, I know I'm going to have to make some changes. But this was a very unexpected problem. Here I'm stepping through the DVRT initialize routine, and this line should set the callback for the RX interrupt service routine. At least I thought it should. But when I follow this code, it's setting the callback for the periodic interrupt timer. I did this a couple of times. I'm still not sure what is going on here. But after this, I decided to forego all the ISR callbacks and just put the ISR code where needed. Basically, I'll be moving some code from the MCC-generated USART file to the DVRuntime file. So here's the MCC-generated RX interrupt code. This should get called when there is data ready to read. And about the first thing it does is read the USART receive data register. Reading that register should clear the receive complete interrupt flag. The rest of the code is just keeping up the circular buffer, and that I don't need. Now the TX interrupt code. This is called from the data register empty interrupt vector. Again, most of the code is dealing with the circular buffer, but the first line I'm interested in is this one. Once a byte is moved to the transmit register, that should clear the data register empty interrupt. Well, I guess unless it's the first byte. The first byte I'm sure will get transferred to the shift register, and then the data register will be empty again, and the interrupt flag set. The other section of interest is this. So when there is nothing else to transmit, the data register empty interrupt is disabled. There's not really anything in the read code, it just deals with the read circular buffer. But the write routine does have something I need, this line here. So when there is data to send, this will enable the data register empty interrupt and allow the transmissions to begin. There are 3 interrupt vectors for the USART. This one is disabled, but probably should keep this code in place, just in case. This is the data register empty interrupt vector. We'll be enabling and disabling this interrupt. And the receive complete interrupt vector. It will stay enabled, watching for valid data coming in. So in the DVRunTime.c file, I'll go to the DVRT initialize function and comment out the setting of the RX and TX callback functions. I'll replace the RX callback function with the ISR USART RXC vector. I'll do the same with the TX callback function, replacing it with the DRE vector ISR. Then I will comment out both the RXC ISR and the DRE ISR in the MCC-generated USART0.c file. The receiver might work with the defines I have in place, but the transmit is not going to work. But I will try and compile, make sure I have everything in place. I'm going to replace these defines with the actual values. I find it easier to follow what's going on with the microcontroller's register that way. Maybe not as easy to move code around, but this is a I'm getting to know the tinyAVR 0 chips project. So for the receive complete interrupt, there are a few items to replace. One thing the MCC generated code didn't have was any handling of errors. Here, the DVRuntime is going to check for serial frame error and buffer overflow. And if there is an error, it will disable and then re-enable the USART. This seems to be one of the differences between the PIC and AVR USARTs. The PICs have a main enable for both transmit and receive. For this ATtiny402, just need to disable the receiver and then re-enable it. At least I think that's how it should work. Now for the data register empty interrupt, it calls a write register function. I'll do away with that in the future, but for now I'll just put in the transmit register value. And this will only be called when it's ready for data, so I'll comment out the data ready check. Here, instead of disabling the transmitter, I'm disabling the data register empty interrupt. In the DVRT_process function, in the section that tests for an empty software transmit buffer, I'll replace this with code to enable the data register empty interrupt. Okay, no compile errors. Let me program the chip and see what it does. I'll start up the data visualizer for the main project. The source is the TTY ACM0, the PIC-Kit5 data stream port. Set the baud rate to 38,400. I'll set the options for the DVRT to 20 millisecond streaming tick and 2 streaming slots. The defaults I have set in the header file. Let me try starting it up and see. No errors. Wonderful. I think that means it's communicating. Of course, it's only going to see global variables. Let me stop it and make a few changes to my code. I'll move the PWM variable out of the mstick function. Change the static to a volatile. I think that will make sure it's a RAM location. I'll reprogram the chip. Go back to the data visualizer. It knows the symbols have changed, so I'll click on the Reload Debug Symbols button, then start it back up. Now it sees my PWM variable, and there is some data from it. Let me start up the time plot. That seems to be about right. Now I want to try to write a value to the PWM variable. Too hard to tell there. The value is changing too fast. Let me make some more code changes. I'll make the PWM value signed and add another variable. Make a few changes to the PWM adjustment code. No errors, so let me program the chip. Back to the data visualizer, reload the symbols. I'll go to the read-write table and add the rate variable. Forgot to start it back up. Yep, rate should be 1. I'll change it to 2. Then let me see what it looks like. Very good. That sure seems to be working. Let me try one more thing. I want to see if I can change the streaming interval. Yep, sure seems like it. The data visualizer is not taking up a whole lot of program space, and I think it could be slimmed down a bit more. I'm just very pleased with that. I really think I might plan on adding that to all the microcontroller projects from now on. If there is only one UART module and it's needed for the project, then that could be a problem. But I'll just have to make it learn to share. Thank you for watching.